Hi all, in this video you will see an introduction to the topic circuit theory. Circuit theory is one of the very first topics that all electrical engineers around the world take in their first year of university. Before we proceed with the circuit theory course, we need to acquaint ourselves with the three assumptions that are made in this course. Firstly, the electrical effects happen instantaneously throughout a system. Second, the net charge on every component in the system is always zero. And third, there is no magnetic coupling between the components in a system. Now, in complex electromagnetism courses, we might have learned that electrical energy travels in the form of a wave, and it will affect the component or electrical components in a not so uniform manner. That is, different parts may have charge accumulated on it, different amount of charge accumulated on it. Suppose this part may have different amount of charge Q accumulated on it compared to this part which have a different amount of charge accumulated on it, that is Q dash, or some parts may experience magnetic coupling, etc. However, in real life, all the electrical circuits that we are dealing with, all the electrical systems are always smaller, much smaller in fact, than the wavelength of the electrical wave. It's much smaller than that. Almost the size of the electrical circuits is always smaller than 5 into 10 to the power of 5 meters. So this is the size of an ideal lumped parameter system, and all the circuits in real life are much smaller than this size, and therefore we can safely say that these learnings that we have done in complex electromagnetism courses need not be taken into account in our circuit theory course. In fact, in circuit theory, only the terminal behavior of the components is mattered, or only the terminal behavior is taken into account. The minute behavioral changes, or the minute changes in the parts of the electrical components are ignored. All the electrical effects happening around us is due to charge Q, and hence it is important to discuss the properties of charge. So here are the three properties of charge. Firstly, charge is bipolar, which means that charge exists as both a positive and a negative quantity. Then charge is discrete, which means the charge exists as independent individual units, and any amount of charge can be expressed as an integral multiple of E, which is the charge of an electron. And third is the actual electrical effect caused by charge. So all the electrical effects happen due to two things that happen to charge. First is the separation, and second is the motion. Now, when two charged particles, let's say Q1 and Q2, Q2, they are separated from each other. Now, the separation of these two charged particles leads to the formation of electrostatic force between them, which can cause the motion of these two charges towards or away from each other. Right? So the amount of energy, the amount of electrical energy required by each of these charged particles to prevent them from moving, that is called as voltage. So voltage is the amount of energy required by each of these charged particles to stay in place, to prevent themselves from moving. That is called as voltage. And when a particular amount of charge, when a charged particle moves over a particular distance in time dt, we can say that the charge is in motion, and this motion of charge leads to what is called as current. Current is nothing but the rate of flow of charge. Current is nothing but the rate of flow of charge. For any electrical element, voltage and current are the two most basic things that has to be defined in circuit theory course. The outcome of an electrical circuit is always something non-electrical. As you can see, it will be either in the form of light, as in the case of this bulb, or sound or heat. Therefore, just by defining voltage and current, it will become pretty inefficient. Therefore, we need to also define power and energy. Energy is the electrical energy. That is pretty basic concept. But power, we need to define. So the power is basically the amount of energy that is used by the electrical elements. So it's the rate of consumption of energy. We can define power as the rate of consumption of energy or rate of dissipation of energy by the electrical components. Without sacrificing the definition of power, we can rewrite this equation as dE by dQ into dQ by dt. And as we can see from the previous explanation, the dE by dQ, that is the amount of electrical energy needed by each of these charged particles to stay in place, is nothing but voltage, and dQ by dt, the rate of flow of charge, that is nothing but current. Therefore, power can be written as this and this equations. Now the sign convention is pretty important, and throughout the circuit theory course we'll be using what is called as Passer sign convention, and it's pretty simple to use, it's pretty simple to understand. If the direction of flow of current, let's say current is flowing in this direction, and the direction of voltage drop, so let's say this is a resistor, and the voltage of this terminal, the voltage polarity is marked like this. That is, voltage is dropping in this direction. It is moving, it is turning from positive to negative in this direction. The voltage is dropping from positive to negative in this direction. So if the direction of current and the direction of this voltage drop is same, then we assume a positive sign for all the power calculations, etc. If the voltage drop and the direction of current is in opposite, or they are different, then we have to take the negative sign. So let's say for a circuit, this is a simple circuit. So in this circuit, the current is flowing in this direction, so in this direction, and the voltage is marked like that. So for this particular resistor, this will be the voltage polarity and this will be the direction of current. Right. So for this particular case, the power will be written as, so this particular, let's name this case 1. So in this particular case, the power will be positive. So the power will be given by plus VI. However, if the current is flowing in the opposite direction, then this will be the flow of current, and here this is the direction of voltage, this is the direction of voltage drop, and this is the direction of current. So it is opposite, that is, it is different. Therefore the power will be written as, this is the case 2, so power will be written as minus VI. That's it. That's all about sign conventions. Thank you for watching the introduction to circuit theory. From the next video onwards, we will discuss more important concepts